Okay, hopefully in this video we'll go on to complete problems 25 and 27. So we're looking for the derivative of y with respect to x of x to the 2/3 plus y to the 2/3 equal 5 at the point 8, 1. So we're going to start by taking the derivative of both sides with respect to x. On the left side we get 2/3 x to the negative 1/3. Then plus 2/3 y to the negative 1/3, almost exactly the same. But because this is y, we treat it as a chain rule and we multiply by the derivative of the inside, which is y prime. And that's equal to 0. So, with finding derivatives at a point for implicitly defined functions, once we take the derivative, we can start to plug things in. For example, I know that x is equal to 1 here. And if I wanted to rewrite this as 2 over 3 times the cube root of x, 2/3 x to the negative 1/3 is 2 over 3 times the cube root of x. And the same thing would happen with y, or with the next term. I'd get 2 over 3 times the cube root of y times y prime, and that's equal to 0. Now I can plug in the values for x, which is 1, and cube root of 1 is still 1, so on the first term I just get 2/3. With the second term I need the cube root of 8, and the cube root of 8 is 2, so I'm going to get 2 over 6, which is 1/3. But that's 1/3 y prime, so I can't add that to the 2/3 there. And that's equal to 0. If I multiply through both sides by 3, that'll get rid of my denominators. And I'll have 2 plus y prime is 0, which means y prime has to be negative 2. So hopefully you can see how we go about finding the derivative at a point for implicitly defined functions. We take the derivative of both sides with respect to x, and then after some minor simplifying, we go ahead and plug in the values for x and y and simplify down to y prime equals something. Let's try that with number 27 then. With 27, we're looking for the tangent of x plus y is equal to x, and we want the derivative of that at 0, 0, at the origin. So we begin by taking the derivative of both sides with respect to x. And on the left side, the derivative of tangent is secant squared. We'll leave the inside alone, and then times the derivative of the inside. So I'll write a little placeholder there saying I need to multiply secant square of x plus y times the derivative of x plus y. Then on the right side, the derivative of x with respect to x is just 1. Alright, all I need to do now, actually, I can start plugging in at this point here. I can't plug into the derivative of x plus y just yet. But secant square of x plus y, x is 0, y is 0. And so that's the secant square of 0, or 1 over cosine square of 0. Now, that cosine of 0 is 1, cosine square of 0 is still 1, and 1 over 1 is 1. So that whole piece is going to become 1. Then we need to multiply that times the derivative of x plus y. The derivative of x with respect to x is 1. The derivative of y with respect to x is dy dx, which is y prime. And that's all equal to 1. So we simply get 1 plus y prime is 1. Subtracting 1 from both sides, we get y prime is equal to 0. Which means that on that curve, tangent of x plus y equals x. At the origin, we have a horizontal tangent there. And I go out to winplot.exe and I graph this tan of x plus y is equal to x, and sure enough, at the origin there clearly is a horizontal tangent there, so that confirms what we've done. And so I'll close that down, and that does it for problems 25 and 27. We'll go on to the next group in the next video.